Okay, so this last example, it's a system of nonlinear inequalities. So you've got two inequalities. These happen to both be parabolas. If you look at them, you'll see that they're parabolas. We can see where the parabolas intersect. So what I'm going to do is I'm going to make this x squared minus y equals 0. So I'm going to make these into equations. 2x squared plus y equals 12. It doesn't graph it, and we do have to graph it. You can't solve these because it's going to be some shaded area, and so you can't list all the solutions. But we're going to find where they intersect, at least, the two parabolas. Okay, so we add the equations. We get 3x squared equals 12, x squared equals 4, x equals plus or minus 2. Okay, so that's just some algebra there that you can work on. All right, if you plug in 2 into the top equation, you'd have 2 squared minus y equals 0. I'm sorry, I'm doing the equation, so this one over here. Anyway, you're going to get 4 equals y. And if you put in a negative 2, you're going to get the same thing. So we get points of intersection, for the two parabolas. You're going to have one at negative 2, 4, and the other one at 2, 4. Okay, that doesn't graph the solutions. It just tells you, oh, we've got two parabolas and they intersect in 2 points. Okay, now I'm going to do the graph because it asks us to graph it, and we have to do the solutions for the system of inequalities. But notice this 12 here. I'm going to have to change my scale. So I'm going to be counting by 2s. 2, 4, 8, 10, and then 12. I'll have to extend it a little bit. 12 will be like up there. Okay? So I just have this teeny graph paper. Okay. Now I'm going to go ahead and graph this equation right here. X squared minus y equals 0. I want to graph the equation. So that's y equals x squared, right? Okay, that's your basic parabola. Oh, shoot, I forgot. I had changed my scale. Let me get those out of there. Okay, so let's see. It'd be 1, 1, and then 2, 4, be like that. Okay, and so we're getting a parabola. Now, before I draw it, I want to see if it's a solid or a dotted. It's solid. And so it's looking something like that. Now, it's helpful to know, okay, where are those points of intersection? 2, 4, okay, I see those. All right, that's that one. Now, I'm going to switch colors and go to this line, and I want to graph that. So I have 2x squared plus y equals 12. I'm graphing the equation. Y equals negative 2x squared plus 12. So this is going to be an upside down parabola. It's going to go through up here at 0, 12. You could plug in 0, you can make a table of values. And then it's going to have this stretch factor, and it's going to be upside down. So it's going to be right here and right here. You could plug in 1, and you're going to get 10. And you can plug in negative 1, and you're going to get 10. So that might help. You make a little table of values here. So I plugged in 0, and I got 12. I plugged in 1, I got 10. I plugged in negative 1, I got 10. And then let's just go ahead and plug in 2. We think we're going to get 4, right? Because those are the points of intersection. And you do. You could plug that in. It would look like this. And then you'd get 4 times negative 2, which is negative 8, plus 12. See, it would all work out. And so we've got a point. What did I plug in? 2? Oh, shoot. Forgot my scale. I needed to have that be 1, right? I plugged in 1 and negative 1. Whoops. So it should have been there and there. You were probably wondering, what was she doing? Okay. And now we're going to have the point 2, 4, and you're also going to have the point negative 2, 4. And so you get this parabola like that. Okay. So you can kind of see the two parabolas, the one orange one and the one in black. Now, what I didn't do was I didn't do the shading. Okay, so let's go back to this one right here, the top one. You can't plug in 0, 0 this time, so you'll have to plug in another point. I would probably pick the point 0, 1, which is right here. So let's see if that point works. If I plug in 0 for, where can I write this? 0 for x and 1 for y. What do I get? Negative 1 is less than or equal to 0. That's true. So what that means is my parabola here, the black one, is all that stuff. Now, you could extend your parabola, you could find more points and extend that. So the green part would be all this part, inside the parabola. I'm just looking at the black parabola. Try to ignore the orange one. Okay, now we're going to look at the orange parabola. Okay, so now we're looking at this equation. You can use the origin because the origin is not on the orange parabola. So you get, if I plug that in, I'm going to get 0 plus 0. Is that less than 12? Less than or equal to 12? And yes. And it was less than or equal to. That's why the orange is a solid parabola. And so yes. So that's going to be inside, the orange parabola, which is all this stuff right here. Okay. Inside the orange parabola. Okay. So where do they intersect? Where do you have both the green shading and the orange shading? So that's kind of hard to tell. But it's going to be all inside here. This time it is. Now, they don't have to work out that way where it makes this kind of weird shape like that. It could have been, one of them could have been greater than or equal to, and then the shading would have been different, but anyway, that's how this one worked out. Okay.